All right, hello everyone. My name is Sharon White and I'm the marketing manager with BLT. I want to welcome you all to our engineering roundtable on productivity tips and tricks. I'll be the moderator for today's chat. Before we begin, I'd like to first tell you a little bit about BLT. BLT, previously known as Bottom Line Technologies, provides custom electronic solutions for commercial and government IC aero applications. We design custom chips, embedded software, circuit boards, and complete systems. BLT trains over 1,000 student days a year and works on dozens of board, FPGA, MP-SOC, and ACAP projects as well. Some of our projects include work on the Mars rover, designing the prototype for HDTV, helping develop satellite radio, and implementing one of the first earliest RF-SOC designs ever done. Sorry, guys. BLT designs are in space, undersea, and everywhere in between. We're an AMD Xilinx certified alliance member and authorized training provider. Today's speakers are Glenn, Cole, and Steve. Glenn is one of our engineering managers and an embedded autonomy and robotics expert. His skills include engineering guidance, navigation and control, or GNC, software and electronics for autonomous systems. He also has extensive experience with managing teams using a wide variety of embedded hardware, middleware, IDEs, build tools, and libraries. Cole is a project engineer with BLT with a focus on RTL design and verification with FPGAs. In his career, Cole is focused on verification and design on software-defined radio, defense systems, and industrial network systems for commercial and defense clients. And Steve is also a project engineer here with BLT with over 20 years of experience in FPGA design, primarily with AMD Xilinx devices. Some of his most recent projects include MP-SOC and RF-SOC applications. He has extensive experience with VHDL and also years of experience with System Verilog for both design and verification. And his specific focus is on designing and implementing difficult algorithms and maximizing performance. Welcome, everybody. Glenn, I'm going to kick it off to you to get started. We have some topics that we want to talk with you today about. These are our topics. And that you can ask questions during the conversation, and then we'll have Q&A at the end as well. So Glenn, I'm going to ask you to start the conversation.
All right, thanks, Sharon, and welcome everyone. So today we're going to go over a few top-level concepts of different productivity, areas of productivity improvement. We're going to discuss each of them in turn and get an idea of what benefits we can get from taking these different practices into our standard engineering flow. I think we can start with the concept of TICL scripting, incorporating that into our design. So that's a good, easy one to get started on. And that really covers when working with tools like Vivado, they have very tight integrations to scripting languages, TICL in particular, that can be used to put our entire design into ASCII text files and automate their creation. And that has a lot of different benefits when it comes to things like revision control, and just making sure that your project has been fully captured. There's nothing hiding inside binary files in the tool.
I'd like to add to that, Glenn. I think the use of TICL is more straightforward when it comes to creating a project, assembling all the files, opening the project. With Xilinx, with Vivado, it can be challenging. It's something we need to overcome in terms of IP integrator. And the reason I believe it is, all of those of us who have been used to doing VHDL or Verilog for a long time, we're used to declaring signals and then declaring modules and placing those signals on the port list for those modules. So that's kind of the way things are connected. Whenever the same name appears on a port of a module, it's connected to the others. However, when you go to TICL scripting and IP integrator, now you're actually connecting all of the ports together using TICL commands. So it's a completely different way of looking at the hierarchy. So one might ask, well, why would I go to the trouble to have to learn a different way to skin a cat, if you will? And so to bring another old adage into the conversation, I would say you can pay me now or you can pay me later. It's very easy to go to IP Integrator and just start stitching blocks together. When you're all done, you can then export your BD tickle, your block design, to a tickle script, but that's not something you would want to work with if you needed to make modifications, or if you wanted to enter that in CM, or even worse, say turn that over to a customer. So we need to come up with a good skill set of tickle so that we can actually write our own scripts for IP Integrator that look like software. They're readable, they're maintainable. And it's a challenge, but it's one that's it's important to put the investment in up front on your projects if you're using IP Integrator to create block designs in Vivado.
Yeah, what I found also about the IP Integrator and using Tickle is that the Tickle console at the bottom, so if you already have like your file built in your block diagram and everything, when you instantiate a new IP, it actually just it's going to print out the Tickle command that it used to generate that IP on your block diagram. So you can, I mean, what I've done is just copy and paste that command into the file, and then it does all the configuration for you. And then of course, the nets are going to be a little painful sometimes, especially when you're working with bigger blocks, but it can help ensure that like you're not missing any situations with your IP. And even if you go back and edit the IP, it's still going to be represented as a tickle command in the console itself, so you can see it. So it allows pretty easy access to creating the scripts and stuff.
Yeah, that's a good point, Cole. I would say that some of the challenges come in if you try to have some customization built into your scripts, say using variables to configure the number of transceivers, those types of things, because if you create those in a block design, now you've lost those variables. You're just going to get the absolute values. So it is a challenge, but you are right. We need to take advantage of what Vivado gives us there in terms of providing us those tickle commands. I think another important thing, Cole and Glenn, to emphasize is just because we're using a graphical design tool doesn't mean that we should abandon our hierarchical design principles.
Yes, definitely not.
And that is actually even more important when it comes to the tickle scripting, because just to give you an example, I inherited a design that had just one tickle script, 6,000 lines long, and I needed to modify it. So that was not pleasant. And so the first step for me was to modularize the design and create hierarchies to try to isolate things from each other. It also cleans up the block design itself.
That was going to be my comment. I can't imagine what that block design looked like.
Yeah. Well, even if they had hierarchies implemented, it was all in one flat file. So that's making things difficult on yourself.
Yeah.
So some of the design principles apply whether we're doing 30 years ago schematic capture, or we're doing text entry and Verilog or VHDL, or whether we're back to graphical IP entry in Vivado.
Yeah, and what you were talking about with like the variables and the configuration on using the Tickle scripts, and you kind of lose that granularity there. One thing is that like Tickle has like the global scope when you're processing everything. So like I mean, I guess if you're taking the time to make this Tickle script to build your block diagram, you're going to be running it often. So you can just you can utilize that global scope and use that to configure everything. And then if, I mean, like you were saying, it's gonna be translated into an actual number, because Tickle is just Tickle's very plain when it comes to variable representation, but it'll still be, I mean, you can go into the script itself and change the variable if you need to, and then it'll be updated every time following. So I mean, if you put the right infrastructure in it, it's relatively easy to manage, especially after you spend, I don't know, like an hour looking at the scripting and everything. So
right.
Yeah. And it is that infrastructure that becomes important, because One of the drawbacks of simply exporting your entire block design using the right BD tickle command is, yes, it's a single tickled script, very large, very unstructured, very hard to read, compared to if you manually construct it.
That's
If you
right.
construct it yourself, there's a number of things that start coming into play here that even more fully leverage the fact that you're working with these text files instead of binary files. You can create a common structure for all of your projects in this tickle environment, a common shell of what files are used for what purposes, what components of the design. You can build up a structure that you can share among all the projects, all the engineers on your different teams to speed up how quickly you're creating projects. And you can modularize specific elements of the design as well, things that are more commonly used. You can create tickle files specifically for that aspect of the block design and use them across multiple designs. So we start getting into some IP reuse here too.
Right.
As we start scripting.
Mhm.
And obviously you can't do that if it's all just within the graphical tool.
That's right.
Yeah. And I think you mentioned this like pretty briefly earlier, Steve, but I didn't even know this command existed until very recently. But I think you said it was BD tickle, and it'll take the it'll take your current block design and export it into a full tickle script that'll recreate exactly as is. So then you can even use that just to just as your baseline. And I mean, like you were saying about that 6,000 line tickle script, you can modularize it a little bit and break it up into separate files.
Very
So,
good starting point. Yeah.
yeah.
That I think the key is don't wait until you've got a ton of components on the display before you export, because as Glenn was saying, it's not in a very user-friendly form. So
yeah,
every time you make a significant command, like you said, Cole, you want to capture that and save that off to a file.
Yeah, and all of this is great for recreating your project, so it helps with revision control as well. So I mean, all of these IPs already exist on Vivado, so I mean, there's no need to copy any of the necessary files over. You're referencing them using the VLNV that Vivado has stored. So I mean, there's no need for it. You can just effectively have your source files and then your script, and that's about it. And then as long as you're using the add sources command to add all of these source files, you can then implement those into your block diagram as well. So yeah, it really cuts down on your revision control size as well.
Yeah, and all this rolls nicely into our next topic, which is the concept of top-down design.
Right.
You know, the idea that we don't want to just start implementing willy-nilly individual pieces of a design that we might be more interested in or might be a better idea of how to do that particular piece. We want to start from the top and sketch out our entire architecture right from the get-go. So we've got a clear picture of what we're trying to do, why we're trying to do it, and can make early corrections to the entire push of the design, as opposed to just finding things willy-nilly as we try to implement them.
That's right.
And building that structure into the processes and the tools that you use, such as using this tickle scripting to construct an entire shell of how your project is going to be built. Things like that can really leverage this top-down design principle to get your project started off correctly from the get-go. Catch problems early.
And I'll confess up front, I'm sure I've violated that principle at times. It's certainly engineers want to jump to the fun stuff, right? Which for a lot of us is the actual putting the design down and then getting to simulate something. But it will cost you in the end if you don't put the work up front to really come up with the best approach.
Yep, particularly if you're working with any kind of size team, particularly larger teams, but even just two people, you need to make sure that you're both on the same page with regards to what you're doing, and even more importantly, how you're going to be communicating between your two aspects of the design. Make sure you don't do anything that's in conflict with what the other guy's doing.
Yeah, and it's even easy when you're doing all this top-down design. You can just implement it into your normal like system design. So when you're going through and defining any like system requirements, and like predefining your interfaces as well. So it can give you like the opportunity to implement things into your design early on, like at the top level. So that way you can effectively build like a black box and or any sort of transceiver simulator, so that way you can have like software if there's a software team working with your design as well, you can get them to the bench earlier as well by instantiating that transceiver early and stuff.
Yeah, one of the very first things you want to design is your interfaces. Create even your ICD documents before doing anything, and then begin implementing those as the first step. And because that, a lot of the problems you can sort out just figuring out how things need to talk to one another. And once you've got those interfaces down, you can start doing some minimal testing on your design as well, even deploying to hardware and testing out your hardware using a very bare bones basic design that just implements the interfaces.
And I think even if you're working on a design by yourself, there's some merit in pretending like you have team members and ensuring you have that discipline that you would need in a multi-person team to think long and hard about those interfaces.
Yeah, I know when I'm designing something, if I don't define, or if I don't hard define everything, I'll try to start combining things, and then I make life hard for myself. So yeah, that's a good way to put it. If you're working by yourself, it still helps to it still helps to keep yourself to those rules for
Yep.
better design practices and everything.
It can also cause you to create a design that's better able to be modified after the fact, refactored, and better able to respond to changes and what you need to be doing. If you've got a clearly thought out plan for how you're going to do things that's well executed, it gives you options. And discipline really is the key to just make sure you're doing this. And there's the general statement that discipline gives you freedom. And this is a good example of that.
Right.
Yeah, the other thing about when you're doing or it goes more so with you're defining your interfaces, and I know you're a big fan of this, Glenn, but as far as verification goes, you can building your tests early, you can kind of know what to expect and start working with that. And you take it a step further than I do, Glenn, but you'll design your tests before you actually design your modules, so that way you're sticking to that as well. But having
Test-driven development.
Yeah, having your interfaces and knowing what you're working with beforehand, especially when it comes to being a verification engineer. When I was doing that full time, that was that was quite a task, trying to figure out what I was working with as far as interfaces went, because I mean, when you're testing a system, you want to test everything that's available. So yeah, that helps. I would say everybody involved, verification software and hardware.
Yeah.
So
The test can actually even perform a communication role on this, because your tests, it's kind of a rudimentary form of documentation as far as what you expect the IO to this module is. And if you define your tests first, that can even be a way of communicating to the engineers who are going to be implementing the actual functionality. This test is what I want to succeed. If you create your module, given these requirements in this test so that the test pass, that means that this has been designed correctly. So it's a good way to offload work within the larger team as well. Another important concept when it comes to working with a team is the coding style guides that you're working off of. It's surprisingly important that everyone involved in a team is following the same style guide. You can have different style guides for the different types of engineering you're working on, like the software team can have their own style guide, the hardware team, the digital design team, their own style guide. There are some variations between disciplines in that, but everyone within the same discipline on the same project should be working off the same style guide.
yeah, and
Yeah,
oh, sorry, go ahead, Steve.
Yeah, I was just going to say something I learned recently from Glenn was the importance in terms of version control with that. It's something I wouldn't have thought of, but just the fact that if you have extra spaces in a file, when you go to look at differences in history and get or your version tool of choice, it creates more headaches.
Yes, you need to have your white space at the least nailed down early in the project, because changing that later breaks your ability to inspect your code throughout its entire history.
Right.
Tabs versus spaces, making sure you don't have white space on underlines, things like that.
Yeah, and then for me, like one of the big things that I'm a fan of as far as like coding style goes is I've worked in environments where there's been really big teams, and the teams are also working with code that's been inherited from engineers who maybe aren't even at the company anymore. And when this is specifically pertains to when I was this example was when I was doing verification, but I would have to go back and create simulators for these like math pipelines, these beamformers, and I would have to analyze code that was written like 4 years ago, and I'm looking at somebody's code and they just have a completely different style from what I've witnessed than what I've been witnessing. So now I have to decode what's working with that. And then it's even more important when you're working with languages that are that kind of abstract the requirements a little bit. So like with System Verilog, you have the option of when you're calling a function, you can instantiate parameters by location. So if you have 3 parameters, if you don't want to use the second one, you can just put a comma, a space, and then another comma, and it will blank out that that parameter and give it the generic value that you assign it. But then what I'm a fan of is applying the dot notation. So you can specifically say dot and then the name of the parameter, and then in parentheses, you put the value that the variable that you're passing to that parameter. And it increases your readability, and it doesn't enforce a specific ordering as well. So you can kind of rearrange your parameters as is convenient. So yeah.
It's that sort of thing that you can codify in your style guide and make sure that everyone on the team is following it. And it's a helpful thing for onboarding newer people on your team. Like, here's a good way to solve this particular problem with code readability. We all follow this way. You should too. It's a great way to communicate that information throughout the team.
What I would say about coding standards, however, similar to developing laws in society, if you will, if the laws become so much, there's so much scope to it, people don't know the law, they don't necessarily follow all the law. And so what I will say that I've seen in some coding guidelines, requirements, is that there are so many specifications on prefixes and suffixes for signal names. And I think that people who develop these requirements need to think in terms of, am I really helping the end product? So unfortunately, I see a situation where perhaps we're worried too much about individual characters at the expense of what is good coding practice for a given language. So this might dovetail, Glenn and Cole, into kind of a rule of thumb about how big should a process be in VHDL, a function or a procedure. If you write a process that's a whole page long, you're probably not going to have a design that's going to be able to run at any significant clock speed, because you're introducing too many logic levels into the process. So coding standards that only focus on the punctuation or the syntax versus the actual approach of writing good code, that's an unfortunate side effect, I think.
Yeah, and I think that also goes back to what we were all talking about this morning with the methodology guide. So I think like a good cross for just a style guide as a whole is to combine the two. So you have your style guide for, or as far as like your naming conventions go, and whether you're using tabs or spaces and stuff like that, that's going to focus on your readability and your clarity. And like you were saying, Glenn, with onboarding, if I was ever handed code that was readable and clear, I think my onboarding process probably would have been 10 times faster in a lot of situations. But yeah, and then with the methodology guide, I think if you combine that, you can kind of avoid those page-long processes that that are going to at least page-long processes that don't have a lot of or that have a lot of tabs to it. But
yeah, and you're referring to the ultra-fast design methodology guide from Xilinx.
Yep.
Yeah, that is a good one. Xilinx and any of the different manufacturers of these tools you might be working with provide good guidelines that are good to incorporate into any kind of coding style guide you use. I find it's very rare that you want to create your own style guide or similar from scratch. There's always some group or some individual who has created a very good, very concise guide that you can use within your team, maybe a mix of different guides. Like for example, for software, for embedded software, a very good one is the Linux kernel coding style guide. Now that's the one that I tend to default to, and it does cover things like you do not want your functions to be longer than a page. You don't want to nest your functions too deeply, things like that are very important as far as improving readability and really the quality of your code. Because if you find a chunk of code throughout any of these disciplines that it isn't really clear looking at it what it's doing, there's probably something wrong in that piece of code. Is good code, working code, almost universally is easy to read code.
Mhm.
Yeah, and calling back to what we've worked on, Glenn, with even the man pages sometimes act as style guides as well, because there was at one time when we were writing a bash script, and there was the concern of whether we should use the parentheses or the curly braces when it came to surrounding the variable names, because we weren't sure um, how it interacted. And I think you had pulled up the bash script manual page, and it even gave a style guide for that. So the information is definitely there with all these documentations. It's just
Yeah.
um,
Your first step should always be to find what the universal convention is, rather than creating your own within your team, your company, your project. There is, in almost all cases, a predefined universal reference for the style guide for any particular language you're working with. Tickle, for example, we start off talking about Tickle scripting. There is a Tickle scripting style guide that covers all of your questions as far as how you should be formatting your Tickle. Now, as I mentioned earlier, sometimes you want to use a mix of different style guides that best fit your application. And this is a case of that, in that Vivado, they have a Tickle scripting guide as well that differs in a few spaces, most particularly of how you want to structure the names of your functions, names of your commands. So in that case, you use the Vivado style guide by default, and for anything that doesn't cover, you go back to the Tickle style guide. And that's how you can set up for your team a common reference for all of you as far as how you want to style your code. There's which standards you use and at what priorities.
Yeah, and even calling to that to mixing the style guides, I think we had to suffer a little bit when we broke tradition when we were defining our or when we were rewriting some of that Tickle, and we realized that we had been working with two tabs or two spaces for our tabs this entire time. And in Tickle, when you use that, the else is going to line up it perfectly with the previous statements in the previous clause. So it's going to be hard to distinguish your else statements and your else ifs from your previous statements. And then I think we had referenced the Tickle style guide, and it pointed out that and yeah, we because two spaces for the tabs came so inherently to us, we were kind of hurting ourselves a little bit, and that style guide corrected us, and now
Yes.
Tickle's readable. So
yes. All right. Now, but the other importance that we mentioned a few times with regards to keeping to a common style guide is, again, revision control. There's a lot of productivity tips when it comes to revision control, particularly when working with larger teams. I think we can all say that we strongly recommend using Git as opposed to the alternative revision control tools. There's a lot of advantages that Git has over its competitors. But yeah, there's some key concepts there that can be helpful as well when it comes to deconflicting people making commits, people pushing to branches. One real simple thing that you can apply within any organization is you want to make sure that you have a common structure for your commit messages. You want to make sure there's, and it's another case where there is kind of a universal standard to follow with a few key things that you should incorporate, such as keeping the titles of your commits under 50 characters. That's all the tools that display commits assume your titles are under 50 characters, and it just is a lot more readable. And then there's also an assumption often that there's a new line between your title and the body of your commit description. There's things like that. There's common universal recommendations for structuring your Git commits, and following them can have a large impact on readability.
yeah, this is definitely all stuff that we can talk about. I think 4 hours on end. So, but
Yes.
Yeah, so I am gonna have you guys take a break, take a breather for a second, and see if we have any questions from the audience. We are at 30 minutes. So anyone in the audience, if you have questions, you want to drop them into the chat panel, we'll be happy to answer any questions. You can ask our panel of experts. So we do have, I got a question, guys. How do you approach design and implementation differently for custom applications versus designs intended for reuse?
So that's, Sharon, that's come up for me quite a bit through my career. And I've been in different assignments where everything was a custom approach. My most recent assignment in the government, however, was where we were tremendously leveraged on many fielded designs. And so I would say first, taking the time to write good modules and test benches that then get put in packages and are organized in a way that can be brought into new projects. And I'm speaking more from a VHDL centric view. Obviously, Glenn and Cole will have a different perspective. Something else that's important, though, in terms of digital design, I think if you're writing for your current application, you don't want to spend extra time optimizing, over-optimizing past whatever the requirements are. I think from what we've been talking about, testability, maintainability, those are really the most important things to make sure you're optimized for in the beginning. However, in digital design, if you have intent on reusing a module, you need to be smarter about thinking that someone's going to come down the road at a later time and maybe use it in a little different way, or more likely, they're going to try to run it faster. And so I can tell stories about people coding blocks without digital design experience. The blocks ran fine at 20 megahertz. They did not run at 60 megahertz. And now we're talking about designs running at 400 megahertz. So it takes more thought if you're trying to design for something that will be reused. And then I would finally say, and this is more of an obvious thing, you need to be even more clear about how you comment and document your work. So you need to just reflect that it's going to take, you're going to have to spend more time doing those sorts of things.
All right, we do have a question from the audience. What was the document name for the Xilinx methodology guide?
Yeah, so I referenced that earlier, and it's the ultra-fast design methodology guide. So this is going to be for Xilinx. It's going to specifically target Xilinx's architecture. So it's going to, if you're working with an Intel part or a Microsemi part, your methodologies are going to be a little different. But the specific Xilinx document number is going to be UG 949. And then, and so you can use that if you just search UG 949 Xilinx. I'm sure the first link that'll come up. They also have documents or they have methodology documents for every version of Vivado as well. So sometimes with the updates, the way that your logic or RTL is interpreted may change. So it's good to make sure you're referencing it specific to your tool as well.
All right, we have another question. When do you choose to use randomization in your design testing?
Yeah, so that's one thing that I've had to deal with quite a bit. I found that randomization is kind of an investment that you have to make because it's going to take a lot of upfront design work, because you have to spend the time of figuring out whether you need to have complete randomization, whether you need to weight your randomization to focus towards specific values. That's something that System Verilog supports, and it's extremely powerful. And then you have to decide whether you're going to do cover groups, what your cover groups are. Especially because with randomization, you may be targeting edge cases. So you have to specify that you want your cover groups to be focused towards your edge cases. So you may have just one cover group for all of your expected values and signals that are going to be interacted with. But then you're going to have your tangentially related signals that may be interacted with significantly less. So you're going to focus on those for your cover groups. And then there's also the matter of making sure that making sure that you are randomizing all of the proper values in there and they're in the correct constraints. So I mean, you get in these systems that are so complex and they have so many inputs, you may have some specific inputs that are going to require specific values at specific times. So then you have to build the logic based off of the randomized values that you're receiving as well. But I would say that for any basic design where you have very predicted outputs and limited inputs, I would say it's best case there because you can just write a simple test by hand. But I've worked with some systems that involve a lot of math, and they're going to have some interactions with rollover and that sort of thing. So you have to, it's best case to use randomization there. I think the randomization that I designed, I ended up running like 4 million times or something like that just to fully verify it. So it's it's definitely got its give and take, but if you want to truly understand that your design is correct, then randomization is the way to go. So
Yeah, that's interesting, Cole. I'd like to also add that in terms of, say, a designer writing test benches, and by test benches, I mean something the digital designer would create himself to just do his initial checks, as opposed to a formal verification process done by another engineer. Generally, I haven't needed to use any sort of randomization for that, but there is one case that I can think of that has happened a lot, and that is it's a good idea to randomize your clock enables in your test benches. I've seen a lot of cases where designs work if the clock enable is either always asserted or it's asserted in some predictable pattern. But if you just start varying, it's on 2 times, it's off once, it's on 3, it's off once, and start playing with those values, it's surprising how many designs may break. And so that is one case, even for the most simple test benches, I say, randomize your clock enable.
Yeah, and actually one of the things that I've found, and with any sort of randomization, you have to have something to compare your outputs to, because I know for a fact I don't ever want to go through waveforms and count the stages that it takes for the output to reflect the inputs. So that's something that I always want to avoid. So you have to also take the time and care for writing your simulators. So like the thing that's going, or the piece of code that's going to produce the same output as your actual code block. So, or as your actual RTL, your module. So that's really important to manage as well. That's good practice in my opinion. I tend to focus on that when I do any sort of verification, because I trust that I can code a system in like a highly abstracted language like Python or System Verilog or something, where you have access to a lot of functions, and then I can use that to test compared to my VHDL code. And also you have access to print statements in languages like that, so it's a lot easier to debug on the fly. And then once you have your hard-coded your proved design, or your proved simulator, then you can compare that to your actual design, and you can automate your checking. And then, like I said, you can run it 4 million times and you don't have to check any of it by hand.
All right, we have another question. The VHDL syntax is verbose. What productivity tips do you have for those new to digital design or for Verilog users?
So having designed with both, and I learned VHDL first, and then I learned Verilog, and I thought, wow, this is easy to read. So the first thing I would say is don't get frustrated. You're going to, if you're like me, you're going to be typing 2 equal signs instead of 1. VHDL is kind of the oddball for a comparison, being 1 equal sign. Things like that, VHDL just doesn't look like many other languages. And so there is a steeper learning curve with the syntax. However, I would say first, keep in mind the benefits down the road in the design process are VHDL, because it's strongly typed, a lot of errors will be caught earlier in the build process during synthesis that, say, Verilog might not catch. In fact, Verilog designers typically should be relying on some sort of linter, which is a separate application that's run to make sure that two buses that are connected don't have a width mismatch, something like that. So that's one thing I would suggest. The other one, if your company allows it, create packages and use types and subtypes. One person I worked with, he created subtypes SLV32 instead of writing standard logic vector 31 down to 0. So if you've looked at VHDL, you recognize that anytime you create a vector, that's a lot of typing. Now, there are other things you can do in your editor, but you can also create subtypes that will save you a lot of typing. Now, there is a configuration management issue because wherever you keep and store those types has to move along with the source. So that's kind of the trade-off. But using functions to help, and even variables. So variables get a bad rap in VHDL because there are some dangers if you try to, or if you inadvertently synthesize a register. But what variables are good for is to store some intermediate value that's a part of a mathematical expression, and then using that to just simplify your syntax. So there are little tricks like that. Don't be afraid to write small functions. Look in the IEEE libraries. In fact, another tip that I recommend to new designers is make a shortcut on your desktop that points to the IEEE libraries in Vivado. Open them up in your text editor, you'll get the syntax highlighting, and you can see how they go about writing all of these functions that are used under the hood. And so then you can get an idea of other functions you might want to write.
All right, we have another question. What classes of files do you submit to source control? HDL, XCI, sorry if I mess this up because I'm not technical, guys, and BD files, of course, but what files are generated by Vivado do you submit?
All right, well, that is a very good question. So a general rule of thumb is you never want to place a generated file in source control. You want all of your source files to be the the pure unadulterated source of everything that then gets generated by the tool in a deterministic way. So you do want to definitely, of course, source control your HDL files, but everything else should be left up to be regenerated by the tool. And the way we do that at BLT to even cover things like the BD files, we don't revision control our BD files. We put all of that inside our Tickle scripts. Our Tickle scripts create our project, create our BD files, reconstruct the project in the way it's supposed to be. And then everything is the same between everyone's repo once they clone and run our scripts. And then those scripts are what gets placed in revision control. And that way you don't need to deal with any irregularities in how Vivado generates the files between versions. You don't deal with the case where until those files are generated, your repo is not in a good state. Everything should come from the source files and from your scripts.
Yeah, and I was actually I was just teaching our boot camp 2 yesterday, and it kind of discusses this as well. So we absolutely take the fewer files approach, but these classes do talk about the more files approach, or effectively like all the files that would possibly be generated. So then you're even committing files that are generated as well, and you are effectively leaving nothing up to the designer. So when they pull from the repo, they have a fully working system that is going to have any necessary files, and you can effectively pull it and immediately generate a bit stream. But that's going to require a lot more work, and there's a lot more room for error, especially if somebody manages to somehow forget to commit like a specific XCI file for an IP or something like that. So there's a lot more room for error, but
Yeah, it really pollutes your history of changes and makes it
Yep.
unclear what changes were made by the tool and which are the actual changes changed by the designer. What is the actual design intent of a given change? It becomes very muddy, and it really breaks a lot of gets more more powerful features. Once you start following all of the best practices with Git, you become creating repos that have a very clear picture of what was changed when, why, and you can even restructure that and adjust that as changes need to be made. You can
Mhm.
almost view it as your individual commits, each making small granular atomic changes, are a script of actions to take upon your code to go from the initial point with no files to the final point with your actual design. And you can go in and modify that script by taking commits out, um, moving around your branches. You get a lot of flexibility once you take all the generated files out, all the things that depend upon the tool and not the designer, and just stick with the minimum set of files.
Yeah, and one of the other things that it references in that bootcamp too is that when you are constant, or when you're revision controlling all of your files, it heavily emphasizes that when Vivado switches versions, so from 2022.1 to 2, that can be like the equivalent of the Grim Reaper to your design, because so many things would require these to be updated, because they're gonna the IP store will be updated and that sort of thing. So
It'll be
yeah,
very unclear what you needed to change
Yep.
because the tool changed to this file versus you had to change your design to get it to work with the new version.
Yeah. So the lesser files is definitely more tolerant to environment changes. So
Yeah, really, you don't want to commit any changes that you personally have not vetted. You don't agree, this is my work, this is what I say has created this intended change in the project. And it's really hard to prove that when you're committing changes made by the tool, essentially. They're not changes that you made on the source files. There's something that just happened to result as a side effect of the tool running. So
yeah.
yeah, you want
Yeah,
to
and
very
yeah,
heavily
so
avoid generated files.
yeah, just to, I guess, just to give like a clear answer, because we talked about it for so long. So the files that we commit here at BLT are going to be the HDL files, the XCL files, and the tickle scripts that are used to build it from there. So it's only going to be those 3 kinds, and anything else is going to be generated by Vivado itself. So.
All right, do we have any other questions? All right, well, I'd like to thank our panelists for joining us today and sharing their knowledge with us. If you're interested in more webinars with BLT, you can check out our website at bltinc.com. We have another one coming up on Korea SOM in December, and we have a workshop on advanced debugging coming up as well. All right, thanks guys for joining us, and I hope we can chat again soon.